Hi, my name is James, and today I'll be talking about Project 2. So, the images that I'll be using today are three photos that I took while I was in South Korea with my sister. So, these three photos consisted of number one, my sister looking up at a museum in a hallway. Number two, a mountain focusing on the big mountain and the river and the bridge. And finally, image three, which was the view of the same mountain, but except a little further to the right with a bendy bridge. So my original vision for this project was to combine two similar photos that I took from uh, two different points of views of the same mountain and then add an image of my sister looking up to sort of make it so that it looked like my sister was looking up towards the other photos. So I decomposed the problems into functions because I knew that I wanted to put these photos together and make some image changes to the photos. So I did that by creating six functions: put together photos, grayscale, Mr. Negative, get rid of background colors, get rid of a half, combine upper and lower, seven, and input coordinate image. So I added some filtering photo functions that changed the pixels of the photos themselves, while the other functions were functions that helped combine photos in a sort of way, either one on top of the other, one side to side, or one into the photo itself. For the functions, I believe that most of the functions acted independently from each other. Therefore, they did not require each other's helps, so I mostly created different functions to do just one unique action. So the function that I'm gonna get more in depth with today would be input coordinate image. Now, what this image took was the full image, the bigger image, a corner image, which is the image that I wanted to put into one of the corners, and the string corner, which asks for which corner that I want to put it in. For example, upper left, upper right, lower left, and the else would just put it into the lower right. So what I first did during my function was I took the width and height of both images, the full image and the corner image, by using with one or with height is equal to the image dot size. So depending on which corner it was, we'll go through different if statements, or like different statements. So if the corner was in upper left, what we did was we used the range of the width and the height of the smaller corner image, and we found the RGB of a specific point of the corner image while looping through every single pixel of the corner image. And then we just pasted it because it's the upper left. Basically, in the upper left, we started at 0, 0, and made our way so that we can cover just the corner image into the top left corner. However, if we wanted to start at upper right, then while using the same X and Y range, which is width 2 and with height 2 of the corner image, we'd also do the same thing with RGB, finding just the same values of the RGB. However, this time we'd put the pixels in just enough to to the right of the full image so that while we're parsing through the whole image, we'd be able to stop right at the very end of the full image, therefore putting it in the upper right. And we did not have to change the Y values because the upper right value of Y starts at 0. And so it's just going to parse down and it's going to be starting at the upper right. However, if we wanted to do lower left, obviously we'd keep the same X values. However, we'd have to change the height because now we're starting at the lower left, which would be at the bottom instead of starting at the top. So we do that by subtracting the height of the full image by the height of the corner image and just parsing through. And finally, we do for lower right, we'd have to change everything because now we want to start at this the point that will make it so we can go down all the way and right all the way without running out of errors out of bounds. And so we did that by subtracting the first width of the full image by the width of the corner image, and then the height of the image, the full image, minus the height of the corner image, and just adding X and Y to their respective places so that we can return the full image. Thank you.